So, good afternoon, everyone. Today, the topic for the webinar, I would say, is an integration, how my PV and Loxone work together. So, the topic would be heating application using photovoltaic. So, that would be the topic of today. And we will start from introduction, what my PV is, what we are doing myself as well, and then we will discuss how our portfolio looks like, how the integration looks like. So let's take time to discuss, because maybe we are short on time at the end. So many colleagues are still joining, I see. But anyhow, we are just in the start. So as I said, the topic for today is hot water, domestic hot water, and space heating from PV. So introducing from my side, you can see my name already. So my name is Talal. I'm handling the international sales. From my background, I'm electrical engineer, and I'm handling the technical sales for my PV for quite some time, for a number of years. And in the middle, we have our uh, director, Andreas Kaiser. So he is more on the director side, on the commercial side, and on the left is our CEO, which himself established this company together with his experience from the PV inverter side, from the solar thermal side, and now over the years he's able to establish my PV. So continuing further, what we are as a company is, yes, we are relatively young company. We started our journey from 2011, and over the years we grow with different product portfolio, starting from 2013 with the DC product. Then we have AC products, single phase, three phase products. Recently we expanded our production facility. So all these things are our milestones as we have aggressively expanded throughout European market. So these products, of course, we will be discussing in the webinars as well. But for now, just an introduction what my PV and our journey is. So as a company, we are an Austrian company. Those who know Austria very well, we are based in the province of Upper Austria. We are very close to Linz, to be exact, in the city of Neusäug we are situated. So here you can see our two buildings. One is our, let's say, commercial building for sales and technical, where I am doing this webinar, and you can see the building itself is covered with the PV panels, and we are doing this heating application on a commercial scale on our building as well. And on our right side you can see this is a production facility. So all our products are made in Austria. So that means it's quality stuff, it's certified stuff. So it goes through rigorous testing phasing as well. So that's all about my PV. So over the years, as I said, we started with different products. Now we are expanding into different market. And let's introduce our colleague, because he has been there for a while. And I would give now mic to Dennis. So Dennis, it's over to you.
Hi, thank you. Good afternoon for everybody from my side. Just a short introduction from me. So I am Dennis van Son. I am head of partner coaching Benelux in Belgium, and also responsible for the Loxone library. So also the cooperation between a lot of third-party systems like MyPV, where we are doing this webinar today with them to showcase how our two systems can work together. A few facts from Loxone. So Loxone started in 2009, just a few years before MyPV, but still also a relatively young company. At the moment, we have 47 locations all over the world. We export to more than 100 countries. And we have more than 1,200 employees at the moment working for Loxone. At the years, we made with our partners more than 3,000 Loxone projects. So we have a lot of running installations that started in 2009. For those who don't know Loxone, I'm taking a little bit our corporate branding, which you can find on the page when you visit our website. Um, we are a company based on smart building, so smart home, smart building. And our core business is, of course, the automation of those installations. Here we can see all categories of those automations. So we have lighting, we have audio, we have access control, we have security, we have shading, we have climate, and of course, in the center, energy. So for today, we want to take a closer look into the energy and to the climate topic, as those are uh, very related to each other. And this is why we are doing the webinar together to showcase this corporation more. Uh, our HQ is also based in Austria, so that's why we know each other as a company, I believe. Two Austrian companies expanding in the rest of Europe and the rest of the world. We see also here in our HQ a lot of PV integration. We use also a lot of energy for the PV to make domestic hot water for the hotel, for the whole office. So that's where we want to take a closer look today and look at a few use cases and how our products can work together. So then I give it back over to Talal.
Thanks. Perfect. So, yeah, I would just one thing I wanted to highlight as well, that please feel free to put your questions in the chat. So, at the end of the webinar, we will discuss them, and eventually, you will get the slides from us at the end of webinar. So, you will get the slides, and please feel free to put your questions in the chat. So you already got introduced from Luxon, what they are doing as a smart home manufacturer, as energy management system. And when it comes to my PV, so from the name you can see PV, and what comes from PV is that yes, you can do different things from the PV. The general idea to get the PV is that you are either using for house loads, or nowadays you are doing the EV charging. What my PV is pushing for its concept is that there are other options. For example, here what we are saying is you can do domestic hot water, or you can do electrical space heating. So there are different options to use PV as a different segments, and that is the topic for today, how you can use PV power for heating application. So moving further, where is the right choice for my PV products? This is a single family home energy chart, which is roughly calculated for a European houses. And here is a comparison between old buildings and new buildings. So in the new building, you can see, yes, the electricity distribution or the energy demand is relatively equal for each segment, meaning domestic hot water and space heating are roughly equal, because the building itself is a passive building, it's a low energy building, so it needs low demand for space heating. So yes, here you can do both application with my PV products. You can do electrical space heating, infrared panels, night storage mediums, etc. You can do both domestic hot water as well as space heating. Then question comes on the old buildings. Yes, in the old buildings, even where I'm living is an old building, and your energy demand is really high. In that case, it's only recommended to do domestic hot water with my PV solution. Yes, technically you can do space heating, but your power from photovoltaic will never be enough to meet that high demand. So the point from this slide is, yes, in the new construction in modern buildings you can do both space heating as well as domestic hot water, but in the case of old buildings it's only recommended to do uh, hot water, domestic hot water. And in terms of our concept, it's pretty simple, that yes, when it comes to heating demand, you are always taking external sources that can be power from the grid, that can be gas, that can be oil, that can be pellets. What we are saying as a company, as MyPV, yes, during the day, use as much power from the sun for heating up the water. And yes, during the night, yes, you can use power from the grid. Even from our devices, you can take power from the grid as well. So there are different options to combine photovoltaic together with grid power, external sources for heating up the water. When it comes to storage medium from the PV, the number one idea is, yes, through the battery. Yes, in the case of battery, you can store energy. Comparing it with 5 kilowatt, still the battery is expensive and it requires a huge capital cost. What we are saying is that you can store more amount of energy in your boiler, in your tank, in your cylinder of a boiler, in a 300-liter boiler. So you can store more amount of energy comparing with less cost. So you can store more amount of energy with less investment. But nevertheless, our system are also compatible with the battery storage as well, which we will be explaining in this webinar, as well as with the Loxone system, how it works. So Dennis will also highlight those things as well. So now we discuss what things, what will be our products, which we will be discussing today in terms of webinar. So we have a relatively small portfolio divided into DC products and to the AC products. DC products are directly connected with the PV, but those are not topic for today. Rather, the topic of today are with the grid connected PV system and those that are compatible with Loxone system. So how our AC products can be integrated together with Loxone management system. There we have two products which we will be discussing in this webinar of today. So as we are preparing with products, we need to know as a background why to choose MyPV, why you need to do domestic hot water from PV. There are a number of reasons. For example, the hot topic, especially in Belgium, in Flanders, that when you are exporting your surplus power, you cannot make money out of it. So you have low feed-in tariff. So you are exporting your surplus power and you are getting nothing from that. So it's rather better to use that power into your house. Other reasons, for example, in Netherlands, you have net metering, which is coming at to the end. Likewise, you need to pay grid fees as well when you are exporting surplus power from a certain limit higher. So you need to pay for that surplus power as well. Other reasons, yes, there's more and more PV power into the grid, and that's causing problem for the grid operator. Other reasons, yes, there can be gas prices, because that was the case during, let's say, 2 years ago when the gas was quite expensive. That can be a reason to get independent from those sources. So what is the concept behind MyPV, what we are doing as MyPV? So in terms of our product, which are grid connected, which are to the grid connected PV system, you have PV panels, then you have a PV inverter, and that PV inverter is sending or is producing the power at house. You are using that power at the house, and there comes a time then there's excess power. So that excess power either goes to the battery in the case when there's a battery, or otherwise that is sent to the grid. What we are doing is that we are reading that surplus power information and we divert that power exactly to heat up the water or heating up the home. That can be heating application, I would say. So this is the concept that we are using precisely precisely the surplus power which is meant to export to the grid. Rather exporting to the grid, we are using that power for heating application. So as I said, we have different products to that. We have AC Elva 2, we have AC Thor, but let's start with the AC Elva 2. So this is a smart heating element. What it means is that that you have a, as I said, you have a PV system, and together with the Loxone, we are getting the information how much surplus power is there. So the master of the system is of course Loxone in that case, and we are getting the information how much surplus power is there. The story behind our smart heating element is that we are doing a linear power control. What it means is that the power at the feeding point is continuously changing because somebody is turning on lights. Even the production from the PV is continuously changing, and we are reacting to that information very precisely. We are reading that information 1 time per second. So you can imagine how precise we are. And every surplus watt is sent to heat up the water. So that's a feature which is, I would say, unparalleled, because there are other solutions, I would say clearly that there are relays and etc. But we are not doing on and off. Rather, what we are doing is a linear power control, which means is that very precisely we send that power to heat up the water. And what further comes with the Loxone system, of course, they have their own ecosystem, and we can be inside that ecosystem where Loxone can prioritize the system. For example, if there's a battery in the system, yes, you can prioritize the battery charging first, and then that power goes to your uh, heating water. But let's discuss more on the AC Elva 2, what this device is. As I said, this is a smart heating element with a linear power control. It's a single phase product with the 3.5 kilowatt of power capacity. In terms of communication, yes, you can have a Wi-Fi with it, you have a LAN connection with it. And in terms of installation, we have separated the part. For example, the heating element, yes, you can put first in the boiler, and then the electronic head unit, you can just connect that once the heating element is inside, so you can connect this electronic head unit to that. More on the case of AC Elva 2 in terms of its application, yes, there are, as I said, there are a number of ways to communicate with the device through Wi-Fi, through LAN, and for example, with Loxone, it's over the Modbus TCP, so you can connect the device over LAN or Wi-Fi with Loxone system. And as I said, there are number of options in terms of you can connect with the heat pump to switch on the heat pumps during, let's say, night time for the backup power and etc. That's also a possibility with the AC Elva 2. As I already explained you in terms of technical side, as I said, you will get the slides and you do not need really to just remember it. But just let's discuss few important things. For example, for the AC Elva 2, because you can see there's a heating element and there's a boiler. So there's a very frequent question from the consumer, from the client, okay, which particular boiler they should choose for AC Elva 2. There's, to be honest, there's no specific brand to choose boiler. Rather, there are two things which you need to take care. For example, one is the internal diameter, which needs to accommodate the heating element. So as I said, one is the internal diameter of the boiler, that should be 45 centimeter, and one is the thread size. So this thread size is very common in the European market. That's the thread size of 1.5 inch. That's also here in the slides as well. So as I said, when you're looking for a particular boiler, yes, you need to take care of these two things. One is the heating element diameter, and one is the thread size. Another thing which might be interesting for technical person is that our devices are working on PWM. They are not working on sine or thyristors or triacs. Rather, they are working on PWM, which is an important in terms of quality, because if you have more thyristors or let's say triacs, then this is causing problem for the grid as well. There can be harmonics in your device in the house, which can destroy eventually your heat pumps, for example. So one of the interesting case study from the AC Elva tool, so it's relatively fresh from Netherlands. One of the customer, he chose AC Elva 2. The reason was he had a big PV system on his rooftop, and he had a battery system as well. And in the pictures you can see it's a 200 liter boiler, and with his big PV system he was exporting a large PV surplus power to the grid, and he was charged with the grid fees. So the reason to choose my PV was also here the improvement of PV self consumption. What it means is that one, because even in his system he has a battery, so once the battery is full, then that power is diverted to 200-liter boiler. So together with that he improves his PV self consumption, and that you can also visualize on the web interface, even on the display as well. So that's just a small reference from the Netherlands, I would say. Again, some emphasis on the PV self consumption, because this is a relatively important topic um, in the market, in becoming important topic. The reason, for example, if we are taking a relatively average system of 6 kilowatt system, yes, your PV self consumption is really in the level of let's say 30%, and yes, you can increase your PV self consumption with the battery, but that comes at a capital cost. What we are saying is that yes, you can increase your PV self consumption with my PV. In this black one, you can increase more PV self consumption up to 80% with my PV solution. But nevertheless, our system can also be combined with battery as well, and you can achieve higher PV self consumption as well. How it works with the battery system is that generally our recommendation is that yes, during till in a day chart, let's say, let's take an example of PV day chart curve. Yes, till afternoon your battery is full, your battery is completely full, and then you have surplus power. Once you have a surplus power, then we start diverting to that into thermal storage. Sometimes customers are asking, could they do thermal storage first and the battery later? Yes, you can do that as well, but recommendation is to do battery first, because what you put inside the battery, you can get that back, but in the case of boiler, you cannot get that power back. Sorry. In terms of planning tool, we have our own planning sorry, we have our own planning tool. So this tool, we call it my PV Power Coach. This tool is free of cost. it can be used for your sales and technical discussion. What is on this tool is that you have a PV system. So you put the parameters, different parameters, for example, how big is your PV system, the feed-in tariffs, electricity tariff, how big is your boiler, and how many people are in the house. Eventually, there are locations from Netherlands, from Belgium, and different regions. What comes out of this planning tool is that you can calculate, estimate the savings that you can make in 1 year. What will be your payback period? So this is a free of cost tool. You do not need to make any registrations even for this, and it's highly recommended to use for your sales discussion. So this, the link is already in the slides, so this can connect you with the further uh, planning tool. So now we have a EC-Tor and AC-Tor 9S. Why we have AC-Tors? These are generally, the terminology for them is solar power diverters. So the principle is the same as AC LVA 2, which we discussed, the smart heating element. Let's go a few slides back. So here you could see that the power manager and the heating element is together. So we also call it all-in-one solution. But in many cases, there's already an existing immersion heater. So in that case, AC 2 doesn't make sense. AC 2 makes sense when it's a buffer boiler, or there's a boiler that doesn't have an immersion heater. So in that case, AC 2 is recommended because it's much easier, that everything is together and you plug it and you run it. But in the case of AC-Tor, it gives you more flexible options. What it means is that you can connect these power managers, these solar power diverters, with the existing heating element. Plus, you can do electrical space heating with them. There are two variants in the case of AC-Tor. On the left, you can see it's the single phase variant, which can do a linear power control from 0 to 3 kilowatts. On the right side, it's the same box, but with higher output, that can do a linear power control from 0 to 9 kilowatts. So we have a three-phase variant, we have a single-phase variant, depending upon how big your PV system is. Again, on the operating mode, we had different options for that, meaning depending on, certainly on your project, but most application is through mode 1, where you are doing domestic hot water. But there are other options. For example, you can integrate the system with the heat pump, the system in mode 5, where you are doing domestic hot water as well as the space heating. So you can always consult with us, which this is the project specification, and which parameters, which installations would you recommend us. So feel free to ask about that, and we would be happy to give a suggestion from our side. So again, on some schematics, how the working principle for the AC Tor is that, as I said, the working principle is the same. You have a PV system, and there's a power fluctuation always at the feed-in point. So together with the Loxone, we are getting that information and we react to that. Here, for example, what I wanted to highlight is that there's already an existing electric boiler which already has a heating element inside that can be connected with the AC Tor. So AC Tor make it clever, make it smart, but without AC Tor, it's just a dump load. On the display as well, you can see how much power it has been diverting. So in this case, for example, it's just diverting 1800 watt, and you can connect different temperature sensors to it as well. In this case, the configuration, for example, is with the 9 kilowatt of single load three phase, but yes, you can also put these heating element at different level of the boiler, or you can connect to different loads as well. For example, in mode 5, again, I would here emphasize that this space heating is generally recommended for passive houses with low energy houses. And here you can see one output is connected to your heating element, second output is connected to your electrical floor mats, and the third output is connected to infrared panel, for example. And you can optimize the temperature individually for the boiler, for the room, and there's no problem in doing that. In terms of communication, yes, it's more or less same with Loxone system. So we are communicating again our Modbus TCP with Loxone, and everything you can see it's plugged on. You do not need to open a terminal box. Everything is just plug and ready to be played. Let's discuss some interesting case study from AC Thor. This is quite old, or I would say early adopter for my PV in Belgium, and a different scenario. For example, in this case, it's a single family home, and with the PV system, plus the user has a pellet heating as well. So what the user was doing is this, that during the daytime he's using power from the sun to heat up the water, and yes, during the night time the pellets heating kicks in to maintain the minimum temperature. So sustainable project with saving, and that's helps him saving environment and plus the pellets. Interesting case, I would say, with Loxone. Here it's a multi-generation home. I would say the building is completely covered with the PV system. I would say it's a special case project because normally you do not see a big PV on a building like this, but in this case it's a 144 kilowatt PV system, and the user has been using multiple AC Tor 9s. So he's immensely heating 100,000 liter of boiler. The reason to do that was, in this case, the water or the PV or the sun is used during summer to store energy for the winter. So the temperature goes up to 95 degrees in the boiler, which you can see it's a big boiler. And together with Loxone, we are optimizing the system. For example, there's a heat pump and there's a my PV system. So heat pump kicks in when there's obviously no more PV or there's no more hot water available in the boiler. But the idea to do that is increasing the PV self-consumption, and he's able to use that uh, power during winter time, which was stored during summer application. Some technical things on the AC Thor. Again, uh, it is supplied with the temperature sensor, so everything is supplied with it. You do not need to buy anything extra with the AC Thor. In case of AC Thor 9s, as I said, it has more power capacity up to 3 phase. And one thing which might be important for the Belgium is that our 3 phase product cannot be used in delta grid. What it means is that there are some cases in Belgium where there's no neutral. So without neutral, you cannot use our 3 phase product. But what you can use in that case is our single phase product. So you can use our single phase AC Tor, or you can use the AC Elva 2. But sorry, you cannot use the AC Tor 9s in delta grid. So that's a thing which you need to take care during installation. And then we have also instructions on how to integrate Loxone together with MyPV. So these are the set of libraries and step-by-step approach. There are different libraries for different products as well. You can have a look on it, and I think Dennis will further highlight in the coming slides how you can integrate my PV product in the Luxon, what are advantages on it. So I would say I will just pass on the slides to Dennis to explain how this integration looks like. And over to you, Dennis, and looking forward to that.
Okay, thank you for the introduction into the MyPV products and what products can be used for what topics about storing hot water in systems. For now, I will highlight a little bit about the Loxone part and what we can do. Because you told us you are great at managing the PV production for the hot water system. But as you already explained, mostly we don't only have hot water in an installation, we have battery, we have a lot of other um, energy users in an installation, and there we come in as Loxone, trying to do an energy management of not only the hot water but the whole installation. Um, Here I'm going to take you a little bit about the energy management topic and how we can integrate MyPV into this energy management system. So here we first start with the topic about Loxone. We try to make the whole building into one ecosystem, so one application where it is clear for a user that they can find all information of their home, their building into one application. Here we see an overview of the energy management, where the customer can find a detailed usage of energy, how much PV we are producing, how much energy we are putting in the battery or in the wall box, or in the building. And depending on the building where we have more energy meters, we can go deeper and have an overview about where our energy is going. Then we also see, Talal explained us, depending on the systems we are using, if we only have PV, if we have a passive system, our self-consumption rate is very low into an installation, meaning that we put a lot of energy into the grid. As long as the amount we are paying for energy and we are getting for energy is the same, yeah, why not do this? Why try to do energy management? But what we are seeing, especially in Belgium, also in the Netherlands, is that the grid is not the battery we hoped for, and that the energy cost, especially in Belgium, if we put energy on the grid, we don't get as much back from the energy we put in the grid than we have to pay when we take it out. This means that we have to look at our energy consumption and try to use as much of the energy we are producing effective in the system. That's where the energy manager comes into play, trying to maximize the self consumption of a building. Depending on the devices we can control in an installation, we can go to some days 100% self consumption. Most days we are going about 90 to 80% self consumption. On the days where there is not a lot of PV, yeah, we use the whole PV system. So we try to look at what we can do. Depending on the customer, so the customer can easily change the priority in the system. We can have a priority of PV, we can have a priority of battery, we can have a priority of our electric vehicle. If we have other devices, the customer is able to change the priority and set what he finds the most important to have done by this day. If he wants to change this, he can change it the other day. So he is very flexible in what has the highest priority. then our energy manager will try to maximize this self consumption into the system. If we are talking about energy, I like to take an example of a home. We have an energy usage of 1 day. If we try to look at the energy consumption we see at the grid, we see we have the usage of the pool control that is standard at night, because in the past we had the cheap tariff in the night and the expensive tariff during the day, but the installer of the pool did not look at the PV system and just programmed his passive system into using the cycling during the night. We see the hot water where we can use the My PV system for. We see the energy usage of the kitchen appliances. Then we have the base load of the installation. And we see again the common household items which are creating peaks in our system. Not only the constant usage is very interesting, because the more energy we use, we produce ourselves, the more interesting it is. But also for Belgium, we have our 15-minute peak intervals. If we get a lot of these peaks at the same time, it is not very interesting, because we have to pay as a consumer for the usage of these grid topics. So this is why we are looking at the energy system. How we can do this, how we can measure this for our market in Belgium, in the Netherlands, also in Luxembourg, we are looking at it. We can use our P1 meter reader interface. This device we plug into our digital energy meter we have in our installation, and we get all the information out of this port. I'm looking specifically for this webinar to these cases. This is basically because if we have the analog meter, then our grid is the battery, and then it does in most installation mostly not make sense to do a lot of energy management, because everything we produce we put in the grid and we just take it out when we need it. That's the basic form of energy management. But from the moment we go to a digital energy meter, then this stops and we have to pay for all the energy we use, and we get not a lot of money back from the energy we put into the grid. Also, when we are looking at installations where we don't have this digital meter, especially in the Netherlands, maybe some meters are not compatible and so on, then we have our energy meter 3 in one phase and 3-phase systems. We talked a little bit about the delta grid. If we want to use the energy meter 3-phase in a delta grid, it is not a problem. This device is compatible for all grids. So we can easily do this. This is also MED certified, meaning that we can use it for billing purposes, especially in larger scale projects. Then, since a few weeks ago, we have also our energy meter for current transformers. This device was really needed, because then we don't have to be invasive into the system to get the energy usage we are trying to look at. Also MED certified, and we have meters from 25 amps up to 400 amps, meaning that if you have bigger scale projects where you are not able to disconnect the power lines, but you want to do an energy management, then this meter is very interesting to use in those installations. Also, if we want to look at other devices in an installation to look at the energy consumption of this, we can easily use a smart socket air to measure devices like televisions or the washing machine or the dryer and so on, so we can get a basic understanding of where the energy is going in an installation. Also, we talked about gas systems. It's also there sometimes interesting to have a look at. That's why we have the MBUS extension, where we can integrate a lot of meters that are already in installations to get also back into the energy management system to have an overview of what energy is used where and when. So first we have to evaluate this. That's the basic start of an energy management system, is to look at where is our energy going and when. Then the second part of, or the first part of energy management is reducing the base load. If we see this base consumption and we look at the building and we see it is constantly using 500, 600 watts of energy, we have a small family home, then I say, wow, this is a lot of energy. Where is this all going? And how can we reduce this base energy load? That is the first part, is to get this base energy down. Looking at power supplies, looking at PCs, monitorings, workstations. How can we look at this constant consumers in an installation? Because if we are not there, they should not consume energy. Here we have an example of a fridge, for example. This is a commercial fridge, an open fridge where you can take drinks out of. If you look at a normal fridge that is constantly on, we see at the base day it uses about 380 watt an hour. So 3 kilowatts hour a day. uh, oh no, 338 watts at the for the day hour. Now, if we look at the business hours and we switch the fridge off when the last customer leaves the installation and we switch it on before the opening, we can already reduce this energy by 40 watts an hour. Now, 40 watts an hour, you think, oh, this is not a lot of energy, but 1 watt an hour is a base cost yearly of €3. So a quick calculation, if I save 40 watts, that's €120 I put in the pocket as a business owner. Now, if we look at when the fridge is used, not only when the first employee enters the installation and leaves the installation, but looking at the business hours of this installation, we see we can reduce it with 80 watts. That's a saving of 20% only on this fridge in the base load settings, to only have it running when we are officially using this installation. So that is the first part of energy management in our topic, is reducing the energy and only using energy when we need the energy. Then you saw our energy usage, you saw our domestic hot water, you saw the peaks. Then it is okay, this energy is needed in an installation. We need all this information, we need this energy. How can we look at putting the energy to use when we have our own production? So this is where we look at our PV system, trying to shift the domestic hot water, for example, in this case, to the PV. But if I go a few slides back, I see it is very easy to switch this peak into the PV part. But we also have this peak and we have this peak. As far as I know, in Belgium and in the Netherlands, when it is night, the sun is not shining, our energy system is not producing energy. So I cannot switch the peaks to the day before, because this is when somebody will shower. And then, yeah, sorry for the rest of the family, but the water is gone. So it is not always possible to put the whole domestic hot water situation into the PV part. So then we are looking not only at PV, but we are looking more to the spot market, where if a customer has a dynamic tariff, this is also included in our software, meaning that if the customer has this contract with his energy supplier, he can just basically also integrate this into our energy management system. So we are trying to shift. During the summer, we have a lot of PV system, but yeah, I'm looking at today. It is a nice day. It's not that cold outside, but it was not a great day for PV in Belgium. So yeah, we need this hot water, because otherwise we have a cold shower this evening. So during the winter, we try to use the energy management system not only for self-consumption of the energy system, but also trying to have the needed energy available at the lowest cost. So basically, when I look here, we shift the domestic hot water, we can shift the pool, we can shift this peak also to the day, because after this, the family leaves, so the boiler does not need to produce extra energy. We can just wait a little bit, and we try to use it as effectively into the PV system based on the priority the customer is giving. Then here we see the same integration where we use the shift also for spot pricing, also for during the winter and so on, where we try to do the most of the energy consumption during the lowest hours, so that we can save here also a lot of energy. It's not saving a lot of energy, but it is saving a lot of costs. We are using the same energy for the grid, but we are paying less money for it. And then we come into this integrations, because yes, we have a lot of energy meters as Loxone. We have a lot of lighting, we have a lot of audio, we have a possibility to charge your car using our wall box. But what we don't have is a heat pump. What we don't have is electrical elements to get domestic hot water. And then we have to look at the integration, where we are now here looking at the integration with MyPV. We saw that they have a Modbus TCP connection. So if the MyPV is connected to the same network of the installation, we can integrate the MyPV system over Modbus TCP. If we have an installation where the network is not suitable for integration of the smart building control systems, MyPV also has the possibility of the Modbus RTU interface, and there we also have the Modbus extension and the Modbus Air, so we can integrate using the network connection or using a hardware bus communication interface, where we are network independent into an installation. So this is where we are looking, and then I'm going to share my screen to have a little bit of a look into the Loxone system. So we talked, or Talal showed us the Loxone library. If we go to the Loxone library, we can search at my PV, my PV, and there we can find that MyPV also did some work there and made already the templates available for their integration. We talked about the LOA2. We can find this Modbus integration here. We talked about the AC Tor system. We can find the integration here. And we see that also this template is done by MyPV. So basically, this shows that MyPV is also aware of the integration between Loxone and their system. And this is to an installer, I think, a very nice and important topic to know, because if there is a question, Loxone can answer this question, but also MyPV can answer this question or direct you to the correct person at Loxone, or we can direct you to the correct person at MyPV, so you get the best information necessary for your project. If we go into this library, this is not only a template where we say, oh, here are a lot of Modbus registers, good luck. Here is the software, do whatever you want. No, here we can also see that there is an integration. It is explained what is possible with the system, how it's integrated in the system. If there are settings needed in the MyPV system, this is also shown. where you can do the correct settings, so that it's not only here is a template. Oh yeah, how do I integrate this on the MyPV device? Yeah, you have to ask MyPV. No, you have this documentation available. And also for the Loxone part, yeah, but how do I use this with Loxone? There you can also easily find that there is a config example. So if you just download this and you have our software on your PC, you can open this. And this is also the great part about the Loxone system. Our software comes included with our system. We guarantee a lifelong software update to your systems, meaning that if we bring new features to the market, then you are also able to use those new features. I see my config file is not opening at the moment, so I'm opening it again. Here we see the configuration. So we see an example of my PV where there is a lot of explanation made. We see also a lot of configuration in this example. So we can find the MyPV system here. We see that they provide sensor data. We see that they provide ectoric data. And there we are controlling the power to the MyPV system. We see this also. This is calculated depending on if we are using our load manager for the 15-minute peak interval, for example, or depending of if we are using energy management mode, or if we are using dynamic spot tariff mode. The status block is controlling what energy we are sending based on the priorities of the installation, if it is energy management, if it is spot price, or if it is load protection or 15-minute interval, for example. There we are sending the correct information to the MyPV system. Here we also see the energy management, where we can integrate this so the customer knows what energy is used. We have our spot price optimizer, which gets the hourly tariffs from the market, so we can use this hourly tariff information for charging our domestic hot water. We see our load manager, which is looking at the grid information and trying to balance our grid connection so that we are not tripping a breaker in the installation, or for the Benelux or the Belgium market, so that we don't go over this 15-minute interval, for example, where we have to pay an extra fee for our grid connection. This we can do with our load manager. And then we also have our energy management. Here we have a specific use case only for MyPV. If you go on our website, we have more explained topics where we not only take the domestic hot water, but we take a lot of energy management examples and try to integrate this into one system. This is what our energy manager do. So we have here a basic config example, which is already made, so that you can easily take this as a guideline and just integrate this into your installation, where you don't have to reinvent making hot water, so to say, but you can also use a predefined example and customize this based on the needs of your installation. This is very fast, very quick, because I had to look at the time, because so with that we don't go over the time. I just want to give you one extra look at what is coming into the next software release. We are looking at spot market, we are looking at PV production, and now we are making a building block for the PV production, where we are going to look at what energy or what weather is predicted tomorrow, so we can more dynamically say, okay, we are going to charge our hot water during the night, because today there is not a lot of PV, so we have this on the lowest tariff as possible. based on the calculation of the PV system you have in your installation. And the only point of information that you have to give is the maximum amount of theoretical power delivery your system can give. And based on our weather service, you get the calculation of the period that you defined into this building block. This is currently in the beta testing or the alpha testing, as we have to say it, and will be in the next software release available for everybody to use. Then I'm going to stop sharing my screen. And we are going back to the presentation, where I am going to hand the presentation back over to Talal, if he is here.
Can you hear me, Dennis?
We hear you.
Can you hear me? Perfect. Yeah, unfortunately I had to change the room, but I'm here still. So I think that was quite amazing with regards to the library and all that stuff. So I feel very informed about how dense options Luxon system has it. But anyhow, I think let's come to the end of the webinar for today. So if somebody is interested to purchase my PV products, of course, we have our sales partner across Benelux region. So you can check on our homepage where to buy my PV, and feel free to connect with them, or you can directly refer to us as well. So you will get the slides from us and contact from us. So feel free to contact myself or our colleague Andreas from the sales side. So we would be happy to support you with any questions in terms of our support as well. Yeah, our support is available at all levels, considering installers, considering uh, the end consumers, the private customers. Yes, we would be happy to support them through their concerns. If there's a problem with the device, of course, just fill out these details on our system and you will get the ticket for that, and we will get back to you as soon as possible. So we are eventually at the end of webinar today. And yeah, I think it was quite a lot of information in a short span of time. So I assume you cannot get everything out of it, but the main idea from our side is that yes, we react to the information from the PV power, and the core performance from our side is the linear power control. So that's a strength, and then you have the strength combined from the EMS system from Luxon. And yeah, from my side, I wish you a nice evening. Dennis, maybe a few words from your side.
Yes, I would thank everybody for joining the webinar. And if there are still questions, please feel free to reach out. And we try to give the needed information for this. And I would also thank you, Talal, for setting up this webinar where we can inform our customers and our partners about the corporation and the benefits both systems bring to each other.
Perfect. Perfect. Thank you. Once again, have a nice evening from our side. And yeah, it was a nice combination together with Luxon, and looking forward to further incorporation into different options which we will be working together in the future as well. So have a nice evening, guys. I will leave a chat for some time open. If there's a still question, we can answer that. But from my side, it's bye bye.